everybody. How are we doing today? How are we doing today? Good. I know it's a little early in the morning, but still. All right, so as you've already heard, my name is Marianne Bellotti. I work on really old computer systems, and I really, really love it. I've spent about 20 years of my life as a professional software engineer. I do legacy modernization, architecture, and system rescue. I get progressively more into a field called formal verification, which is basically math for computers. And I'm here to talk to you about what makes it so hard to modernize old technology. Because it is really hard, right? Close to 80% of legacy modernization projects are just gonna fail. That's not me saying that, that's Red Hat saying it. They're just not gonna get off the ground and they're not going to accomplish their goals. And of all legacy modernization projects, 27% completely overrun their budget, like orders of magnitude more expensive than people thought it was going to be when they started. And a lot of what I do is work with people on how do we make these projects successful and how do we avoid common pitfalls with them. So, if you remember nothing else from this talk, this is the most important thing I'm going to say. It's where I start with all the people and the teams that I work with. It's my guiding North Star. Legacy tech is successful tech. Because what trips people up a lot is when they come into legacy modernization, they kind of go, oh, this old, gross system. They devalue it. They don't appreciate it. They don't have empathy for the people who came before them and built it and maintained it. And that kind of sets the whole project on the wrong tone right away. So what do I mean by this idea of like legacy tech is successful tech? Well, if it wasn't successful tech, we'd have the easiest legacy modernization project in the world. We just shut the damn thing off. And then it's like, all right, great, going home, that's great, problem solved. So we can't do that with a lot of these systems because they're being used. They're active. People are using them. And often people are using them in really critical places. They're essential functionality. A lot of these systems, particularly the ones that are like 30, 40 years old or older, were the first time people tried to do a particular thing, and the first time they tried to do it with computers. And so they've been trudging along for decades, providing this really critical functionality. And because of that, they're also foundational. We've had them around for a while, so we've built other systems on top of them. And then we've built other systems on top of those other systems. And so making any changes at all is not just about that one system and its performance, it's now about a whole ecosystem of other systems and their performance. And so if you find yourself in a situation with like really old technology that you're not sure how to get rid of, congratulations, you have a successful system that people are using and that is providing a critical functionality. So I'm gonna start us off with a set of myths that people believe about modernization that tend to trip projects up before they even get started. And the first one I hear all the time is people start off their conversation about like what they want to do with their system by saying, well, this technology is too old. I'm like, well, all right, cool. Why do we have to get rid of it? Because it's too old, Marianne. We have to get rid of it. It's too old. A lot of times this comes up when we're dealing with mainframes and COBOL, and that feels like a fair point. But the problem with this argument of technology is too old is multifaceted. First, most technologists are incorrect about the actual age of their technology. One of the fun experiences for me is lately I've been dealing with a lot of people who have really old Java applications. That's their legacy. And they'll call me up. I can hear that some people also have old Java applications flying around somewhere in their infrastructure. And so they'll call me up and they'll say like, we've got this old Java thing, it's gross, we want to get rid of it and update it with a new, modern programming language like Python. And this always brings a smile to my face because if you know a bit about programming language history, then you know that Python is actually older than Java, right? So we're kind of wrong about the age of things. Most of the things that we associate as new, particularly in the language fields, are 10 years old. And if you think about it, no one ever complains about how the design of a light bulb hasn't really fundamentally changed in a really long time, or how like a fork or a knife hasn't changed in a really long time. We never really complain about the age of our technology when we're talking about other forms of technology. So for me, age isn't an important factor. I don't really care how old your technology is. I care about your ability to run it. I care about your ability to maintain it. Maintenance is most important to me. So when someone comes up to me and says, like, our technology is too old, that's why we need to do legacy modernization, the things I want to know is, like, okay, are we on a language or a framework that's still being actively developed, right? Or is this abandoned and it's just sitting and no one is maintaining it, right? If it is being actively developed, are we capable of keeping up to date with its current builds, right? Can we do security patches? Can we do updates? Or is there some reason why we're blocked and we can't keep track with like the most current version of it? And then like, as technology changes, our perspective on like what protocols we're using and how we're configuring everything and how we orient everything tends to shift over time. And so are we able to sort of integrate with those newer products, those newer services we want to take advantage of? A lot of times when we have an outage on a mainframe, it's almost never the mainframe that is actually the problem. It is the 17 layers of Java middleware that has been put in front of the mainframe in order for it to talk to the internet, right? So this idea of like, can we take this old technology and actually get it to communicate with this new technology is not insignificant, and it is a factor that comes into play when we talk about why we want to modernize technology. Okay. So some takeaways from this concept. First, beware of shiny object syndrome. Like, we're all very faddish in what technologies we get really excited about. Just because something is being chattered about a lot on like the forums and a Hacker News or what have you doesn't mean that it's the right fit for what your organization is trying to do. I see a lot of systems where when I look at their architectural diagram, I think to myself, how does that even work? Like, how does this thing even operate? There's no way that works. And then I'm always surprised to find out, no, in fact, it does work, right? A lot of systems can work, but they can have a lot of hidden costs associated with getting them to work. And something working once doesn't mean that it works at scale, right? So when we decide to undergo a modernization effort, we really have to be very clear about why we're moving to the new thing. What is the value of the new thing? What are we hoping to get out of it? So, myth number 2. Let's just rip it out and replace it, wholesale. A lot of times, since I work really heavily in software, a lot of times we're talking about like full rewrites, but this is also like a hardware thing. Let's just pull it out and just replace it with something new. And this seems like a really great idea, right? But the thing to think about is those kind of modernization efforts typically involve what's called a hard cutoff. You turn on the new system, you turn off the old system, and then you pray that everything goes exactly the way you want it to. And that can be an extremely risky migration plan. So you have to be able to answer this question of like, all right, if we turn on the new thing and we turn off the old thing, and it turns out when you have live data coming across the new thing, it doesn't work, or there's some sort of bug or some sort of complication, can you turn the old thing back on? Like, what happens then, right? What's the strategy after that point? And so if you have an answer to that question, this might be the right approach for you. If you don't have an answer to this question, or you haven't even thought of that question, then this is probably not a thing that's going to go really well. The big thing about rewrites and replaces is that you have to think about how the modernization effort is communicating its value to people who are not technologists and for whom this isn't really all that important, right? So what happens a lot with rewrites especially is that you end up spending a lot of time and a lot of effort getting back up to the same level of functionality that from the business perspective you already had. And so the business side looks at these kind of modernization efforts as, well, what are you giving me that's new? And that causes your MVP and your roadmap to expand its scope beyond what is feasible to do and tends to tank modernization projects right away. So we want to really focus on value, and we want to be able to communicate value. We want to be aware that these rip and replaces tend to allow us to drift into adding new functionality on top of modernization. So, takeaways here. Once the software is written, it can be a long, slow process to migrate off of the old system. And so understand what that migration looks like, right? And then don't forget that rewriting or ripping something out also means retraining. It also means onboarding the users onto something new, and make sure that you're accounting for that as well. And maintain discipline around what your MVP is. Don't overload it with new functionality, trying to get the most value to the stakeholders. So I'm going to dig a little bit deeper on this concept of value, because value for technical people and value for non-technical people are often very different things. And there are 4 areas where you can provide value that is easy to understand for non-technical people. And they're not really in a ranked order. I just put them in an order that felt right at the time. So the first one I'm going to talk about is performance. If you improve the performance of the system, it is faster, it scales better. That is a value that people understand. But it has to be at a level that is noticeable to non-engineers. If the only reason why I know there's a performance increase in the system is because I looked at a dashboard that told me there was a performance increase, and otherwise I have exactly the same situation and the experience that I had before, that's not really going to communicate a lot of value to non-technical stakeholders. So it has to be noticeable to non-engineers. It has to be significant. Second area is user experience. If when I log on to use your system, I have a better experience, I understand what's going on, I don't have confusion about like what I do next, I have a nicer, prettier experience, that's a thing that I'm going to value. Third area is stability. Bugs, uptime, things like that. This can also include security, but again, it has to be noticeable to a non-technical person. I have met very few business people who really care how many critical vulnerabilities there are in the backlog. I know it breaks a lot of people's heart to hear that, but like generally speaking, they don't really care very much about that until it comes time for an audit. But when they have to send out a press release because something terrible has happened, they care about that. So you can put security in this third bucket, but it has to be something that's noticeable to your non-technical stakeholders. And then the last is new features, new functionality. People get very excited about those sort of things. So understanding how people perceive value and where that value is about what you're going to build and what you're going to do with your modernization project is pretty important. And so then the last myth I'm going to cover is, all right, fine, we're just going to migrate to this other thing. We're going to use this software as a service. We're going to ship it out to a third party. We're just going to move it off to somebody else. They've already done all the building. They've already done all of this. It'll be fine. So we're going to put this into 3 different categories, right? We have our COTS and our software as a service. And these things are great. If you have a generic business problem that lots of other businesses have, by all means, ship it off to software as a service. Have a lovely day. But the more unique your particular problem is, the more customization you use, the more edge cases you're introducing, the more problems you're potentially opening up, the less stable the software is going to be over time. So you have to be really honest with yourself about like how great of a fit is Salesforce for this issue that I have, because Salesforce is a wonderful product with lots of customization options, but I've also seen people do some pretty weird things with it, right? And that does not always go well for the organization. The same with managed infrastructure, like the cloud, right? Cloud is great if you don't have economies of scale and you're fine with using managed services that you can't move to another cloud if you change your mind later on. But if you are sensitive to things like that, there's a lot of vendor lock-in that comes with cloud. There's a lot of hidden costs that come with cloud. It may not be the right approach necessarily. And then the last one is one that's super popular right now in modernization efforts and like breaks my heart a little bit. They just go, all right, we're going to just do this low, no code, no thing. We won't have to worry about engineering teams at all. We got this lovely drag and drop interface. We're going to just arrange everything exactly the way we want it, and then we're going to click the button, and it's going to generate all our Java applications for us. It's going to be amazing. Maybe, right? Low-code, no-code solutions are really great if you're dealing with internal services where you have a finite number of users and you have a general idea how many there are. So like maybe you have 200 people that will ever use this system. And you know approximately when they're going to be working on this system, and you know what they're going to be doing on them. They get a little bit more complicated when you're talking about like public-facing services where you could potentially have millions of users using it, and they could use it in wild and unexpected ways because they don't work for you. So like YOLO, they can just do whatever they want with like what's on the public internet. And so these kind of solutions, because they're automatically generated, they don't have the the brains of a software engineer standing behind them figuring out the best way to optimize everything. So they produce a lot of junk code. They can have performance issues. They can have security issues. And if you put it out in a place where it's got to scale really fast, it can go down really fast as well. I dig a little bit more into the cloud because this is a thing that comes up quite a lot these days. These are some problems that people don't consider when they think about shifting some or all of their infrastructure into the cloud in order to take advantage of the scale that Amazon and Microsoft can bring to the table. I had an organization that I was working with quite recently kind of dig into like why their AWS bills were so high, and they realized they were paying over $10,000 just in taxes because of the way they had broken up their infrastructure across regions. Data ingress is the one that I highlight for people every time, right? Where does your data start? Where does it originate? And is there any point in time where you have a legitimate business reason to pull it off the cloud because you will get charged for pulling off the cloud? So this idea of like where data starts here off the cloud, and then we move it into the cloud, and then we move it out of the cloud, and then we move it back into the cloud, that is going to cost you a lot, almost invalidating the cost savings of the cloud in general, depending on what scale you do it at. So, and then the last little bit that people sometimes don't factor in that I think might be most relevant to this audience is that, you know, some of us work in organizations where we care about the nationality of the people who are involved and have access to our infrastructure. I spent a lot of time working for the federal government, and they care a lot about the idea that Amazon might have some foreign nationals digging around in their data center. And so making sure that you are with a provider that understands that and can accommodate whatever your particular needs are in that regard is something that people sometimes don't factor in when they're pursuing these things. So again, like identify what we think the value is. Like if we're doing this because we think there are going to be cost savings involved with moving everything to the cloud, cool. Why? How are those cost savings happening? Are they happening because we're decreasing our staff? We no longer have to hire data center people? Are they happening because we're no longer investing in our own hardware? Are they happening because we get to operate at a scale we haven't been able to operate in before? Understand what you're trying to do and to what extent you're trying to do it, right? If you need to move everything to the cloud, what does everything mean? Is it all your data? Is it all your users? Like, what are we going for here? So this is the thing I think a lot of people miss about technology. And often when I give talks, I give a slightly longer introduction of myself, and I disclose to people that my actual background isn't so much in computer science, it's in anthropology. And so what has always interested me about technology, and what particularly interests me about legacy technology, is that it's an artifact of how people and organizations think and how they see the world. Like, technology is about people. And so successful technology projects, whether they're modernization projects or they're new projects, are all about people and how people are communicating with one another and how they're organizing with one another. And so here are some three examples of this. 2 of them are bad, 1 of them is good. So let's start with the negative things. 91% of security attacks start with phishing emails, right? So they start with a human being being tricked by another human being and giving access to something that an attacker shouldn't have access to. 59% of performance issues are triggered by some sort of failing in a human process that's associated with the technology. A lot of the ones that have been like, you know, kind of marquee problems lately have involved somebody like overwriting a configuration file by accident or deleting a record that shouldn't have been deleted by accident. But there are also like really positive sides to people involved in technical systems. 80% of maintenance work is what we call non-corrective maintenance. Corrective maintenance is, I found a bug in this system, I opened a ticket, you went and fixed it. Or I found a security vulnerability in a CVE that's relevant to our system, and I opened a ticket and you fixed it. Non-corrective maintenance is somebody sitting at a desk in front of a computer, thinking about a system, thinking about how it could be better, and then proactively taking the opportunity to make it better, right? So 80% of maintenance activity comes from that human beings invested in their technology and wanting to make things better. And so A lot of times when I come to a community of people to talk about legacy modernization, before my talk starts, I get a lot of questions about like, are we going to cover like IBM mainframes? Are we going to cover old Windows 95 installations that are lurking somewhere in your stack? Are we going to cover this? Are we going to cover that? And the answer to that is no, because every legacy modernization story starts exactly the same way. Every legacy modernization story starts with us not doing maintenance and operation work when we should be doing it. And so the most important thing to understand when you're doing a modernization project is if our solution to the modernization problem is to take out a piece of technology we've been ignoring for a decade and replace it with a new piece of technology that we're going to ignore immediately after it is up and running, then we are going to end up in exactly the same place within a few years, right? We cannot solve a problem that was created by ignoring maintenance and operations with just putting something new in there, right? So the thing that is really important to me and what I structure my work around is this idea of operational excellence. How do I define operational excellence? Well, operational excellence starts with goals, right? What do we want the system to be able to do? In software, we call this SLO, a service level objective. I'm sure that's a term familiar to some, if not all, in this room. So we figure out what our goals are, what the system needs to do, and we figure out how we're going to monitor it, what we should see in whatever dashboards or logs we have in order to know whether or not it's meeting those goals. We also want to make sure that we've tested this system, particularly for failure, like not just tested that the happy path works, but we've actually like deliberately shut things off or deliberately sabotaged them to make sure that we know how it recovers and it recovers correctly. And then we make sure that the people who need to be responsible for keeping this system healthy actually have the resources to do it. A lot of times, I used to tell my team when I was working heavily in the federal government, I was basically running kind of like a SWAT team where something would go wrong, something would crash and burn, and we'd be sent in to another organization to help them stand it back up. And I would tell my team all the time, your job is not to figure out what the solution is and fix it. Your job is to figure out roughly what the right thing is and then find the 5 people who've been screaming into the void this entire time because they already knew that, and then bring them here, because what we're going to do is we're going to make sure that the resources and the ability to do the thing that they've always known were the right things, right? So you need to make sure that the people who are in play to keep that system healthy are actually able to do that. Okay, so what does this look like, right? This looks like, we break this down into 3 kind of phases. The first is that we set our goals, typically with the business side of the organization's buy-in. What is that value add? Let's put those goals in some tangible form. Then we look at the system as it currently exists. Presumably at this point, we've figured out how we're going to monitor the system, or we already have an existing way of monitoring this system, and we kind of collect the data of like what the baseline state is, and we compare it to our goals. How far away are we? And then we kind of structure our work based on that. Where are we going to get little incremental improvements in those goals? Like, how are we going to get there? I'm a huge fan of, like, rather than going for like the wham bam, everything is fixed now because we did this big project, going for like the, oh, if we change that, it'll get a 5% gain, and we'll get an 8% gain, and we'll get a 2% gain over there. And at the end of the day, we're going to walk away with this huge boost in performance or security or what have you, but we're going to do it in a very low-risk way because we sort of precision targeted where the bottlenecks were. We identified where the bottlenecks were, and then we kind of went for each one. And then the last phase is like being very honest about who our organization is culturally and where they actually want to invest their time and money. An issue and a question that comes up quite a lot, particularly with things like COBOL, is people will say to me like, okay, Marianne, so do we hire a bunch of new college grads and teach them COBOL? Or do we rewrite all of our COBOL into something else so that we have a larger pool of available engineers that we can hire? And that's a really hard question because I've seen organizations do both really well and be successful with both really well. Again, I don't give a shit how old your technology is. If you have a COBOL mainframe buried somewhere and you're happy with it, by all means, like, let's keep it going, right? Keep the dream alive for Grace Hopper, right? But if you can't hire people and you can't transition the knowledge and you can't maintain the system and you're just kind of like, it's just sitting there and like no one actually knows what the COBOL is doing or has any idea how to get it to do something else, that's the problem. So it's like, which one of those things should you do? Well, it depends on, as an organization, how good are you at retraining people? Like, how interested are you in investing time and money in actually retraining people? If you work in an organization where this is not something they value, then deciding to hire a bunch of college grads and teach them COBOL is probably the wrong approach. So you have to be really honest about where the organization has budget and can get budget to spend time and energy with certain approaches. Okay. So as the COBOL story kind of proves out, there aren't any silver bullets. There isn't. I don't really talk about specific technologies in these kind of talks because what worked for one organization is not going to work for your organization necessarily. But the silver lining with the idea that there are no silver bullets is that it means that every single one of these myths that I sort of laid out for you could work in a particular context. So for example, when people say our technology is too old and we just have to get rid of it because it's too old, like, that's probably the right attitude to have when we're talking about hardware. When we're talking about something where the manufacturer for it went out of business or there aren't enough manufacturers, it's supply chain issues, that's probably the right attitude to have, right? When we talk about it's better to completely rewrite this. That's the right attitude to have if you've had some sort of fundamental shift in your business requirements so that the process that is ingrained in your systems is no longer the proper process. We see this happen a lot with like regulation changes. Like Congress has like decided to sneak something in an appropriations bill and now you have like 6 more things that system needs to do. Like if that's the situation you're in, a rewrite might actually be the right approach, right? And just replacing it with some sort of software as a service or a COTS product, you know, if that's a popular product that lots of organizations use, you get huge benefits from that standardization. You get like lots of eyes on it, better turnover and security problems. So there are advantages to all of these approaches. It's about figuring out which one is right for your organization and for what you have the resources to do and for where you are at the time. And to put it more simply than that, technology is contextual, right? At the end of the day, technology does not exist for the sake of having technology. I know that's sometimes hard to believe because there's a new iPhone every single year, so it feels like sometimes we do have technology simply for the sake of having technology. But we create technology to solve problems. And so different organizations can be in the same spaces and feel like they have the same problem, but actually have slightly different problems because of who they've hired, where they're operating, how much money they have, how much of the market they have, all of these kind of things. And so you really have to go with like what the organization itself values, what it's willing to invest in. These things matter a lot. And communicating why we're doing what we're doing when we're modernizing a system in the language of those values makes a huge difference in the ability of these programs to be successful. But then the last thing to sort of keep in mind is that even when you feel like you know these trade-offs and you have understood and you've mapped them all out, as the organization ages, they're going to change. Like an organization, a startup of like under 100 people is a very different landscape than the same organization 5 years later when it's got maybe 1,000 people and it has way more revenue, which is a completely different organization than when it's now a multinational corporation and it's trying to serve all of these different regions. You really have to have this ongoing conversation with your technical systems about what value they're providing and how best to deliver them. So that's it for me, guys. Again, I'm going to be at the pool, at the cabana, signing some books. Please feel free to come by if you have any questions and you just want to chat. It was great talking to you all this morning.